All right, we're right at 4 o'clock. Welcome everyone to our Thursday webinar. And thank you, so many people joined us and registered and have signed up. So we're so excited to see you, and hopefully we'll be seeing you again in the new year. But I'm Liz Perry, Crow Canyon. Really excited about today because this is a partnership that we do each year with the Pueblo Archaeological and Historical Society. So stay tuned to hear more from Doug in a moment. Before we get started, we'd like to start with our land acknowledgement because Crow Canyon is here on the traditional lands of the Pueblo, Ute, Paiute, Dene, and Jicarilla Apache people. We like to always start by acknowledging the first people of this land, the human people, the animal people, the plant people, water people, and rock people. We ask permission of the first people to enter this space and make a promise that our words, deeds, thoughts, and actions will be honorable to them. Our work is not possible without Indigenous people in the past, present, and future, and we respectfully recognize and honor ancestral and descendant Indigenous communities for their contributions to all humankind. At Crow Canyon, we are grateful to all Indigenous people, and we support the preservation and protection of cultural traditions, ancestral connections, and sacred lands. As usual, if you have lots of questions during the presentation, if you could pop them in the Q&A instead of in the chat, they're less likely to get lost. If Zoom gives you a headache, we are live streaming on Facebook, and this and our past webinars are also on our YouTube channel. If you have not signed up, please do. We have advertised our 2025 travel programs, so just check out our website, crowcanyon.org. And we have some amazing trips coming up next year, starting with our first trips in April. An amazing birding program this year, the Green River, usually hugely popular, Glen Canyon, Bears Ears, O'odham. So please go ahead and check out our trips. There are still spots available for 2025. And as always, a huge thank you. This is an entirely free webinar series that we do because of all of your donations. Thank you to everyone for donating. Some people donate every time they register for a webinar. We're so grateful for you. We could not do it without you. And speaking of donations, this is that time of year when everybody is thinking about where they would like to make their year-end contributions to their favorite organizations. We support ourselves and a lot of our partners here in Southwest Colorado. Next Tuesday, December 10th, is Colorado Gives Day. And I think Taylor will pop the link in the chat. It's kind of, we love Colorado Gives Day. We give to a lot of other organizations as well. This is, they have a wonderful matching program this year. So if you actually donate through to Crow Canyon through December 10th of next week, Tuesday of next week, they actually they boost donations. If you sign up as a recurring donor, which you can do on the Colorado Gives website, they match your first gift up to $100. So we don't like to leave any money available to nonprofits on the table. So please consider, if you are looking at making your year-end contributions, to signing up to be a Crow Canyon recurring or single donor, or just make a donation through this particular website to get a match. So without further ado, I will hand it over to Doug to introduce Dr. Surovell.
Thank you, Liz. First of all, I'd like to thank you and Taylor and the Crow Canyon for partnering with PAWS last couple of years and having these December talks with Dr. Surovell. Again, thank you. My name is Doug Baxter. I'm president of the Pueblo Archaeological and Historical Society, and it's easier to say PAWS, the acronym PAWS. PAWS is a chapter of the Colorado Archaeological Society, and we're located in Pueblo, Colorado. And we're lucky enough to be located in an area of the state rich in prehistoric and modern history that our group explores and investigates. I'd like to invite everyone to check out our website and our Facebook page by Googling the Pueblo Archaeological and Historical Society and learning what we're all about. I'd like to now introduce Dr. Todd Surovell. Dr. Surovell is a professor and director of the George C. Frisson Institute of Archaeology and Anthropology at the University of Wyoming. Dr. Surovell specializes in archaeology of the hunter-gatherers and the first peoples of the New World, with specialization in in the Paleo-Indian period, the earliest period of American archaeology. Dr. Surovell received a BA in anthropology and zoology from the University of Wisconsin-Madison in 1995, an MA 1998, and a PhD 2003 from the University of Arizona. He has expertise in human behavioral ecology, quantitative methods, and I always stumble on this word, Todd, archaeometry. Is that how you say that? Archaeometry.
Yeah.
Ethnoarchaeology, lithic technology, and geoarchaeology. He has worked on a diverse range of topics in archaeology, although most of them stem from his first love in the discipline, the initial human colonization of the Americas. Most of the field work has been in Wyoming and Colorado, but he has worked throughout the American West and in Israel, Denmark, and Chile. From 2012 to 2017, he completed a 5-year ethno-archaeological project in the Duka reindeer project with the Duka reindeer herders in northern Mongolia. And he also gave us a talk about that a year or so ago. He is an excavator at Barger Gulch, Locality B, a Folsom site in Middle Park, Colorado. And he recently wrapped up excavations at the Laprelle Mammoth site, a Clovis kill and campsite in Converse County, Wyoming. He has published more than 75 articles on Paleo-Indian archaeology, lithic technology, and geoarchaeology, Pleistocene extinctions, ethnoarchaeology, and other topics. He's also the author of 2 books, including one of his works at Barger Gulch, published in 2022. But first of all, I'd like to congratulate Todd on his new baby, 10-month-old baby boy. And now I'm going to turn it over to Todd.
Well, thank you, Doug, and thank you, Liz, and thank you, Crow Canyon, and thank you, Pueblo Archaeological Historical Society, and thank you to all of you in internet world. It's really gratifying to see 200 plus people out there, including friends and colleagues, including people who participated in this project, collaborated with me on it. So with that, let's get going. Let me share my screen. And Doug, can you nod if you can see that?
Yes.
All right, are we good to go then? Let's do this. Today, I'm going to talk about a non-controversial topic: when people first arrived in the Americas. Obviously, I'm kidding. This is one of the most controversial topics in all of archaeology. And what I want to do is give you maybe a different approach to the problem, one you haven't seen before. This is actually work we published 2 years ago. In PLOS One, I have a big list of collaborators who I list on this slide. I'm going to name them quickly. Some of them have joined us today. This Sarah Lon at History Colorado, Barbara Crass, the Museum of North, Joe Gingrich at Ohio University, Kelly Graff at the University of Kansas, Charles Holmes at the University of Alaska Fairbanks, Robert Kelly and Marcel Kornfeld and Mary Lou Larson at the University of Wyoming, Kate Krasinski and Brian Weigel at Adelphi University, and Spencer Pelton, who's the state archaeologist. Required all of these people because we pulled together a heck of a lot of data as a team to be able to do this work, to look at stratigraphic integrity of a series of sites across North America, to look at this question of when humans first arrived. And I'm going to guess this is an angle you probably have not seen before unless you're familiar with his work. If so, you get to hear my spin on it. So just to give you some broad context for the colonization question, I'm going to start with some well-known background that I'm sure most of you are familiar with, but North and South America were the last of the major land masses on the planet to be settled by humans. Certainly there are oceanic islands that were settled much later, but of the major continents that were colonized by humans, except for, of course, Antarctica, North and South America, were the last that remained unpopulated by humans. The timing of this, everybody would agree, happened in the Pleistocene epoch. But exactly when is what we argue about. And at the time during the Pleistocene, during the Ice Age, during the late Pleistocene, when the Ice Age was at its peak, sea levels were lower by about 100 meters or 300 feet, exposing a dry land connecting Northeast Asia to Alaska and Yukon Territory, a landmass we call Beringia, allowing humans, of course, to walk across what today is the Bering Strait, but during the Ice Age, let's say 20 to 40,000 years ago, would have been habitable land. Interestingly, once they reached the unglaciated parts of Alaska and Yukon, moving further south was complicated because the way was blocked by massive ice sheets. The Cordilleran ice sheet in the west that grew out of coalesced montane glaciers and coastal ranges in the Rocky Mountains, and the Laurentide ice sheet in the east that sort of center of mass over Hudson Bay and the Great Lakes, those coalesced, blocking the way south. So sometimes later, after this initial colonization in Beringia, people moved into temperate parts of North America via an inland route, a coastal route, or maybe both. We don't know exactly. Let me tell you what we do know is that by around 14,000 BP, we have pretty clear, uncontrovertible evidence of humans in the Tanana River Valley of Alaska at sites like Swan Point, shown here, dating to just over 14,000 calendar years BP. Once we get further south of eastern Beringia, though, things get a little more complicated. In general, as you know, probably know, it's widely accepted that people were south of the ice sheets by around 13,000 years ago. This is evidenced by what we call the Clovis complex, or fluted spear points and associated artifacts, faunal remains, human remains, found across the continent dating to around this time. Although many archaeologists accept that people were in the Americas well before that date. Some would say they were in the Americas, 1,000, 1,500 years before that date. Some would say they were in the Americas 5,000 years prior to that. Some would say they're in the Americas 30,000 years prior to that, and some yet would say they're in the Americas more than 100,000 years before that. And this is the basic question I want to address is, if we look at archaeological sites from across North America, from the perspective of stratigraphic integrity, what does the evidence tell us? So I mentioned the Clovis complex, and here are just a simple map showing that Clovis points, these fluted, beautiful, large, fluted, bifacial, basally indented spear points, are truly a transcontinental thing, at least in the areas south of the continental ice sheets. And they date to a fairly narrow time period from about 13,100 to 12,700 years before present. We find them from the west coast to the east coast, from the northwest to the southeast, down into Mexico. And as we move further south, fluted projectile point tradition continues, although the points start to change a little bit in morphology. These points and other artifacts commonly associated, but not exclusively, with megafaunal remains. You may have seen a paper that came out yesterday looking at the diet of the mother of the Anzac child using stable isotopes that suggested at least one Clovis individual's diet was heavily based on mammoth, at least 40-some%. Very large mammal-based diet. Anyway, nobody questions Clovis. This is a widespread archaeological signal, consistently dated to a very narrow time period. But of course, before Clovis, we have all kinds of interesting things that are argued to be archaeological, clear evidence of humans, and older, that extend the date of human occupation, such as footprints in White Sands National Park in New Mexico, projectile points and other chip stone and bone from the site of Cooper's Ferry, argued to be upwards of 16,000 years old, a very famous site in southern Chile of Monteverde, with excellent organic preservation, argued to be 14,500 years old, 1,500 years older than Clovis, approximately, but on the other side of the planet in far southern South America. Most people think this is sort of a settled argument that pre-Clovis is real. I want to tell you it's not a settled argument. And there are plenty of us, especially those of us who are experts in this discipline, who don't believe this evidence, or at least are skeptical of it and don't think it's unquestionable. And I just want to give you one example of, why I say here in the second point on this slide where I say if these sites are as old as they're claimed to be, they're somewhat anomalous. Okay, so let's just take the case of white sands. I mean, it's one thing to have footprints that are directly dated, that are human footprints at white sands that are 22,000 BP, and to say, yeah, humans were in this salty, desertic, or arid part of New Mexico 22,000 years ago, because there's the evidence for it. If that's true, this implies massive gaps in our current knowledge of the prehistoric world. Let's look at the prehistoric world. Let's look at what the world looked like 22,000 years ago. Here's white sands. At the time, this is the height of the last glaciation. We have massive ice sheets covering much of northern North America, another massive ice sheet covering northern Europe. In terms of humans on the planet at this time, you have people throughout Africa, you have people in the temperate or the southern parts of Europe and Asia. But Siberia, we can't even demonstrate that anybody is there, nor in Northern Europe at this time, nor do we have clear evidence of anybody in Eastern Beringia and Alaska at this time, okay? So if we really have people in New Mexico at the last glacial maximum, how did they get there? When did they get there? And why are they basically invisible throughout the rest of the Americas? Again, what this implies is there are massive gaps in our knowledge, or perhaps that these claims aren't exactly what they appear to be. I'm not going to tell you what the right answer is because I don't know, but what I do want you to, my point is that when you see these claims, especially major claims that hit the popular press about these pre-Clovis sites, there are reasons to be skeptical of, because they imply these huge gaps. Okay, so in that framework, let's look at this basic question of is Clovis first or is Clovis not first? The classic debate, but I want to give you kind of a new approach, a new way to think about this problem. On the top, a spear point from the Laner site in southeastern Arizona, found associated with Columbian mammoths. On the bottom, a coprolite or fossilized feces argued to be human and pre-Clovis from Paisley Caves in Oregon. Stratigraphic integrity, what does this mean? Let's start with some basics, some definitions. This refers to the degree to which the locations of artifacts as recovered by archaeologists, especially in the vertical dimensions, I mean stratigraphically speaking, reflect the locations or the surfaces onto which they were discarded in antiquity. Basically, did we find them where they were discarded? Sites that have high stratigraphic integrity, artifacts remain on the surfaces onto which they were discarded and within the stratigraphic units by which they were buried. It's kind of a Pompeii situation, right? Imagine Pompeii is sort of our dream scenario of stratigraphic integrity. You have this beautiful occupation surface. Very tragically, Vesuvius explodes and everybody is left on this, perfectly preserved on this single surface. We can imagine a different scenario, which is actually typical of most archaeological sites, lower stratigraphic integrity, where artifacts move around after they're buried. They're moved from the surfaces onto which they were discarded, and they become associated with different stratigraphic units, both above and below those onto which they were originally discarded. And you can imagine why this might be a problem in this debate, because if we have artifacts moving deeper into stratigraphic deposits, it gives the impression that they're older than they actually, it could give the impression that they're older than they actually are. Right? So how does this relate to this debate? After artifacts are deposited by people, processes of disturbance, all kinds of processes of disturbance, like rodents digging through sites, roots moving through sites, freeze thaw, shrinking and swell, all kinds of disturbance processes can cause artifacts to move downward into association with older sediments, giving the impression that they're significantly older than their actual ages. So let's imagine the dream scenario where we have some occupation, people live, these red polygons represent artifacts discarded on a surface that's about 12,400 years old. Dream scenario is it's not disturbed at all and everything remains exactly on that surface. Well, in reality, the archaeological record rarely looks like that. Disturbance processes cause things to move, and the archaeological record from, say, a single occupation might instead look like this. And if we interpret now this distribution literally, right, we could say, well, the oldest artifacts we have here appear to be, let's say, over 14,000 years old. But are they really? No, they're actually about 12,500 years old, but they've moved down after the fact due to some processes of disturbance. So how do we tell these things apart? Before we get to that, I wanted to just show you two real-world examples of this. So the Murray Spring site is a Clovis mammoth and bison kill in southeastern Arizona. There's an associated campsite. But Vance Haynes, when I took classes from him at the University of Arizona, would talk about their excavations at Murray Springs. And the way he described them were quite amazing to me, especially given what I later encountered in more typical archaeological sites. So here you see this mammoth at Murray Springs in the bottom right here. And it's buried by this really dark sediment that they call the black mat. And what Vance described was they could peel down through that black mat very carefully. And when they got to the very bottom of it, they'd peel off the last of the black mat and the artifacts would be sitting on the surface just beneath it. He described it this way in the Murray Springs book. Napping areas were carefully excavated to maintain precise proveniences insofar as possible. In 4 areas, the lithic debris occurred on a well-marked surface and was collected by peeling back the overlying 5 centimeters of sediment with small tools, thus locating flakes in situ. They're all just sitting on the surface. He said 1/4-inch screens were used to check the effectiveness of recovery. Less than 1% of the collection came from screening. They were able to recover 99% of the collection on this single surface by careful excavation. Really, really well preserved. At least this part of the site was incredibly well preserved, high stratigraphic integrity. In contrast, let's look at a site that I had the pleasure of digging. In fact, this is an amazing site, a big fulsome campsite in Middle Park, Colorado called Barger Gulch. But this is sort of more typical of archaeological sites in the degree of stratigraphic integrity. Here we're looking at our main excavation block at Barger Gulch, and we're looking down on it. And we're just looking at mapped artifacts that we mapped in situ with the total station. We have some 5,500 artifacts here. And it looks like this really nice occupation surface that's preserved this fulsome activity area. And to some extent it is. But when we rotate this and look at it in 3 dimensions, what you'll see is, in fact, that this site is highly disturbed. So when we look through this, what you can see is that there's a clearly discernible occupation surface where you see this dense blue line. That's the occupation surface here. But you can also see that there's this cloud of artifacts that have moved up and down from that occupation surface because this site has been shallowly buried for 12,800 years and has been exposed to burrowing animals, sagebrush roots, tree throws, all kinds of things that has caused these artifacts to move up and down. And when you look at Barger Gulch, when you look at artifact densities as you dig down through it, you'd start at the top and you'd start digging. And we'd start finding artifacts at the very top of the site and very young sediments. And as we dug down, artifacts would increase in density. And then about 40 centimeters beneath the surface where the occupation surface is, we get this big spike in artifact concentration. That's the occupation surface. And then it would slowly decline as you dug down. If you looked at an artifact distribution like this, you might ask, are you really sure this is a single occupation? Because there's another way you might interpret this, right? You might say, well, you've actually got, more than 12,800 years of occupation here. This is a repeatedly occupied site. And what this curve is just representing is, say, occupation intensity over time. But what's really cool about the archaeological record is that these are actually testable hypotheses. For example, right, what we could do is say, well, if we just look at things that we know are fulsome artifacts, do they pattern the same way? And if they do, we can then gain confidence that all of these things are artifacts from the top to the bottom of this stratigraphic section. And if we look at fulsome artifacts, diagnostic ones, projectile points, preforms, and channel flakes, we find, in fact, they pattern exactly the same way. This tells us yeah, this is probably one occupation that's just been exploded vertically by disturbance processes. There's no indication of later occupations at the site. This is just a single Folsom occupation that has been highly disturbed. It's got moderate stratigraphic integrity. You know, we can still see an occupation surface, but yeah, things have moved up and down. Another way you might look at this is arguably the best way, is to look at refitting and conjoining artifacts, things that fit together, like what you see here is a really interesting refit sequence of a Folsom Point manufacture where they took a biface, they intentionally broke it into pieces, they fluted those pieces, they broke the preform when they tried to flute it for the third time. And we can fit all those things together. So we know all those things were touching, right? And then if we look at their spatial distribution, so let's rotate this distribution here. What you see is that things that were produced in exactly the same moment during a single flint knapping episode, we find refitting above and below the Folsom occupation. Basically, all this stuff appears to be from the same basic event. So if we look at the distribution of refitting artifact pairs, what we can see, and that's what you see on the right, artifacts below the Folsom occupation surface refit to artifacts at the Folsom occupation surface. Artifacts at the Folsom occupation surface refit to artifacts well above it. Artifacts at the occupation surface refit to artifacts at the occupation surface. All of this tells us we're dealing with a single event that has been disturbed. The stratigraphic integrity has been modified, and this is absolutely typical of archaeological sites. It shows us that these things have moved up and down. Okay, so the take-home point here is that all sites, to some extent, are affected by these post-depositional disturbance processes, some more than others. But the second thing that's really important is that when the stratigraphic integrity of archaeological sites has been impacted, there are usually really telltale signs. You can usually figure it out if you do the studies to determine that. There are other ways we could show the same things that I've just shown here. These are just two ways to demonstrate that the stratigraphic integrity of Barger Gulch has been impacted, and we're dealing with a single occupation that's moved up and down. Okay, so let's go directly to the question at hand. We were inspired by the simple observation that some of these sites argued to be pre-Clovis seem to show evidence of having been affected by post-depositional disturbance processes, meaning that raises the possibility that the association between artifacts and older sediments, whether dated by radiocarbon or OSL or some other methods, these associations might be spurious, which led us to think about new ways to measure, to assess the degree of stratigraphic integrity of archaeological sites, because if we could do that, that would allow us to directly compare a series of sites, leading to new research opportunities. So just a very brief outline of where we're going moving forward. Here's how we did it. First, we simulate the archaeological record. So we create simulations of disturbance of archaeological sites, because what we want to know is, in known cases, in cases where we know how much archaeological sites have been disturbed, what should they look like? What should a not very disturbed site look like? What should a really disturbed site look like? That if you simulate it, then you know what happened to a simulated site, and you can look at the properties that happen in simulated sites. On the basis of those simulation results, then we're going to develop a way to actually measure stratigraphic integrity, to reduce it to a single number. I'm going to show you this equation again. Don't freak out. We're not going to dwell on it. But we're going to be able to reduce stratigraphic integrity to a single number, so we can look at any site and say, what does its stratigraphic integrity appear to be? Does it appear to be highly intact or not so intact? And then once we have that measure, we can apply it to a range of early sites to test the Clovis-first hypothesis to see whether it holds up. Okay, pretty simple approach. Okay, so very quickly, how do we simulate this? Well, you combine a depositional model and occupation history in mixing. So basically what we do is we say, okay, we have some imaginary site where we have sediments accumulating at a rate of like 0.1 millimeter per year. That means that in 18,000 years, 1.8 meters of deposits will be laid down. So we have sediments just constantly being laid down at this slow rate. We have 7 occupations that happen every 2,000 years. The first one at 12,500 BP and the last one at 500 BP. So this produces this nice, we're looking on the right at a layer cake of these occupations in an undisturbed site. These different colors are actually a bunch of dots representing artifacts. And this simulated scenario produces this beautiful layer cake where we have 1, 2, 3, 4, 5, 6, 7 occupations, 2,000 years apart. And then what we can do is simulate disturbance. We can move artifacts randomly up and down every year at some rate. There's really 2 things affecting how much we move them, how deeply artifacts are buried, and some mixing rate. We can say a really high mixing rate means we have a lot of disturbance. A low mixing rate, we have very little disturbance. The reason why depth matters is that as things get more deeply buried, they tend to be less susceptible to disturbance. This for obvious reasons, right? It's because most disturbance processes happen from the ground surface. So once things get really deep, they tend to be less disturbed, okay? Okay, so if you simulate that, and just to give you a quick animation, as we increase the level of disturbance, these different occupations start to blend together, okay? So here are the results of that simulation. So on the right, you see these back plots of these simulated sites with rates of low rates of disturbance or low rates of mixing at the top and high rates of mixing at the bottom. Okay, those are what we call back plots. This is just we're looking through a site from the side, and every dot represents an artifact. And on the right here, we're just looking at counts of artifacts by depth. Okay, so when we have very little disturbance, we get this nice layer cake where these occupations are discrete stratigraphically. You have gaps between them, they're easily identifiable. If we look at counts of artifacts by depth, we get a lot of artifacts, and then we go sterile in our excavation. Then we get a lot of artifacts and we go sterile. A lot of artifacts and sterile. And as we mix these sites more and more with increasing levels of disturbance, these distributions go from multimodal, meaning they're really peaked, to really unimodal, meaning there's no real gaps between occupations. In fact, if I didn't color these occupations differently, you couldn't even see them. They've all started to blend together. Okay, so really clear signs of what an undisturbed site and what a really disturbed site should look like. If it's very disturbed, these stratigraphically discrete occupations blend together and artifacts move above and below the surfaces onto which they were originally discarded. You also get this downward skew in the distribution as artifacts move into older deposits. So notice here we just get these big peaks and a pretty symmetrical looking distribution. As we disturb the sites a lot, they tend to get this downward skew as artifacts are moving down into older deposits. They kind of taper off as you go down, taper off to 0, as opposed to a rapid drop from a really intensive occupation down to 0 very quickly. Another thing we can show is that, as you mix sites more, the apparent age of the oldest artifacts gets older. So again, the initial occupation in the simulation is 12,500 BP, but we can say how old do the deepest artifacts appear to be? And as we increase this rate of mixing, we get artifacts going deeper and deeper and deeper into these deposits, giving the impression that people arrived there, up to 6,000 years prior to their actual arrival in this simulated situation. Again, this is not the real world, but we're just using this to try to help us kind of hone our interpretive tools for understanding the real world. So how do we turn this into some simple number for assessing the degree of mixing? It's really simple. Don't dwell on the sigmas and the equation down there, but basically this equation captures one really simple idea. That sites that have very little mixing, we see dramatic changes in artifact count from level to level. So on the top, we have 500 artifacts in the first level, then we go to 0. Really dramatic change. Then we go back to 500, then we go to 0, then 500, then 0. But if we have a lot of mixing, we have very small changes in artifact count. So if we're to dig this site, we're going from 150 to 200 some, back to 150. artifacts sort of occur continuously, and there's not a lot of change from level to level. And that's what this measure that we call the ASI, or the Apparent Stratigraphic Integrity Index, is trying to capture, is as we're digging down through sites from level to level, do we have dramatic changes in artifact density as we're moving down, which would imply a highly intact site, or do we have very slow changes, which would imply a much more mixed site? So let me just show you how this thing is calculated. It's not that complicated. By the way, we call this Apparent Stratigraphic Integrity Index because you can imagine a situation where we actually have a very intact site that is repeatedly occupied that would generate a vertical density distribution that you see on the bottom right here. For example, if occupation intensity slowly increased over time and then was relatively constant, and then we don't have any mixing, we could certainly produce a distribution that looks like this. So I will say this measure alone can't demonstrate stratigraphic integrity. It's just, that's why we call it the Apparent Stratigraphic Integrity Index. It says that if a site looks like this, it appears to be not very intact. If you really want to know, you need to do those things like I showed you at Barger Gulch, like look at refitting, for example, to see whether, to what extent artifacts actually are moving up and down. But what's nice about this ASI is that it varies from 0 to 1 for most cases. So if a site has very low stratigraphic integrity, the ASI is close to 0. If it has very high stratigraphic integrity, it's close to 1. So it's a very intuitive measure, okay? So this just shows some examples from simulated cases of what the ASI value means. And in general, we can think of this as once we get to about 0.3, well, I would say below an ASI of 0.3, we have a lot of mixing and all these occupations tend to blend together. An ASI of above 0.3, you start to be able to pick out discrete occupations, and above, let's say 0.45, you get very discrete occupations that show very little mixing between them, okay? And just to show you how it's calculated, it's actually not that difficult. So this is one excavation unit from Barger Gulch. And this is just the number of artifacts we found in each 5-centimeter level. So in the first level, we found 5 artifacts, and then 1, and then 8, and then 12. And all you do is calculate the difference in artifacts between the levels. So going from the first level to the second, we got 4 fewer artifacts. Going from the second level to the third, we got 7 more artifacts. Going from the third to the fourth, we got 4 more artifacts. And you do that for every level. Okay, so down here we go from 135 to 35, so we get 100. After you've done that, you calculate the average of those differences from level to level. And then you divide that number by twice the average artifact count. And that gives you your ASI. And this very simple measurement can tell you to the degree of stratigraphic integrity. And for this particular excavation unit at Barger Gulch, we get about a 0.47. So yeah, Barger Gulch is mixed, but you can see it does have a fairly discrete occupation surface. Stuff has moved up, but it's not that bad in terms of stratigraphic integrity. It's actually pretty typical for a North American archaeological site. Okay, so now that we have this way of measuring stratigraphic integrity, let's look at the big question. And let's ask this question: when and where do stratigraphically intact and discrete archaeological components first appear? If Clovis-first is right, then we should first see them in eastern Beringia in Alaska, in Yukon, and then later in the Clovis period. If Clovis is not first, we should see them south of the ice sheets prior to Clovis. It's a very simple prediction, right? In order to test this hypothesis, all we need then are vertical counts of artifacts by excavation level from a bunch of sites. So that's what my colleagues and I pulled together. We have all worked on these sites: Alm Shelter, Wyoming, Bob Kelly, Broken Mammoth, Alaska, Kate Krasinski provided me those data, Dry Creek, Kelly Graff, Helen Looking Bill, Marcel Mary Lou, and Marcel Kornfeld, Mary Lou Larson, et cetera, Holtzman South, Brian Weigel, Johnny Minnesink, Joe Gingrich. The excavators of all these sites spent years digging these sites, carefully producing these vertical density data that we could use to test and apply this method. The pre-Clovis sites from south of the ice sheets were taken from the published literature. I invited the researchers of these projects to participate in this study. They said, go ahead and use our published data. So we did. And then we answered this question using these sites. So 12 sites in all, 8 with hypothesized pre-13,000 components, and 4 multi-component Paleo-Indian sites post-dating 13,000 BP. So the pre-Clovis sites come from 2 places, eastern Beringia. Again, I mentioned Swan Point early on, Holtzman South, and other ones about over 14,000 BP, the oldest components there. Owl Ridge, Dry Creek, and Broken Mammoth. We have our pre-Clovis sites south of the ice sheet, which are Deborah, Friedkin, and Galt, which are literally right next to each other, about, I think, 700 meters apart in Texas, Cooper's Ferry, and Idaho. And then these later multi-component Paleo-Indian sites, including Shawnee Minnesink, which importantly has a Clovis component there. So what does the world look like if we measure it this way? So here you see backplots. You're looking through Eastern Beringian, early Paleo-Indian sites. So every dot here is an artifact. And what you can see very clearly in these backplots on the left is that you have these multi-component sites where you have these stratigraphically discrete components. Now there's some mixing, and some of these components are less discrete than others. But if we look at these vertical density plots on the right, they show up in the way you would expect for sites that are relatively stratigraphically intact. And you see that the ASI values are relatively high, ranging from 0.367 at Broken Mammoth to 0.546 at Owl Ridge. So if we plot these Eastern Beringian pre-Clovis sites, they show varying levels of stratigraphic integrity, but they're generally high. A lot of integrity here. We can clearly identify these different components and relatively little mixing. These components are generally separated by zones that are archaeologically sterile. How does this compare to pre-Clovis sites south of the ice sheets? Well, let's start with the Galt site in Texas. There's many localities of the Galt site. We only had these data for, I think, what's called locality 15. I'd have to check that. But what you can see here is that it looks very different than what we see in Eastern Beringia. We have 2.5 meters of deposits, but chipstone artifacts are distributed throughout with no clear stratigraphic breaks. The oldest artifacts are argued to be more than 16,000 years old here. And if we calculate an ASI, it's much lower. It's 2.18. It's very different than what we have in Eastern Beringia. Here's the Deborah Friedkin site, a neighbor to the Galt site, 1.5 meters of deposits with artifacts throughout. The oldest artifacts argued to be 15,500 years old. We have no discernible stratigraphically discrete archaeological components. If we calculate an ASI, it's very low. It's 0.045. Cooper's Ferry, we were only able to get data from the deepest part, the pre-Clovis levels of Cooper's Ferry. But again, we get this same pattern that you see, in fact, at Friedkin, of this tapering down to nothing pattern. You see the same thing in the bottom levels of Cooper's Ferry. Over 4 meters of deposits here, but again, we only had data from the bottom of the Cooper's Ferry site. Artifacts here argue to be upwards of 15,800 years old. And again, if we calculate an ASI, very low, 0.185. So if we compare pre-Clovis in the north to pre-Clovis in the south, we get a very different story. Pre-Clovis sites north of the ice sheets show high stratigraphic integrity. Pre-Clovis sites south of the ice sheets, at least these pre-Clovis sites, do not. What about Clovis? Well, here's the Clovis component at Shawnee Minnesink, which is incredibly stratigraphically discrete, pretty much limited to 15 centimeters of vertical depth. You can see the artifacts are incredibly tight with an ASI of 0.676. So we enter the Clovis period and we immediately get very discrete, identifiable, stratigraphically identifiable occupations. What about other sites? Hell Gap, Wyoming is a very famous site, a stratified Paleo-Indian site with most of the Paleo-Indian sequence preserved there, and you can see multiple components. They're not as stratigraphically discrete as you see at other sites, but still an ASI that's much higher than we see for pre-Clovis sites at 0.367. Alm Shelter, a deeply stratified site with more than 11,000 years of human occupation. Some discrete occupations, but some mixing, a similar ASI there of 0.386. Helen Lookingbill, another stratified site in Wyoming with more than 10,000 years of occupation, 0.343. They're plotting in the same area as Broken Mammoth, but in this medium stratigraphic integrity zone. So let's recap. We use simulation to determine the characteristics of what sites of varying levels of stratigraphic integrity might look like. From that, we developed a statistical measure of stratigraphic integrity, what we call the ASI. So we know that this is a good measure of stratigraphic integrity for simulated data, meaning for sites that we know what happened to them, we know it works because we know what happened. And we know it measures stratigraphic integrity fairly well. We applied this to a series of actual sites from across the continent, and this measure patterns at continental scales for the earliest sites in the Americas. And we don't think this is a coincidence. So to wrap up, the oldest sites in the Americas with discrete and unmixed occupations occur in eastern Beringia between 13,000 and 14,200 BP. South of the ice sheets, similar sites first appear in the Clovis period, and there are many of them that are this way with these intact, discrete archaeological components. And then, of course, they continue after Clovis. You see the same thing. But there are no sites in the Americas south of the ice sheets that exhibit an unambiguous, stratigraphically discrete cultural occupation with large numbers of artifacts of unquestionable human manufacture. This is, in my opinion, an unquestionable fact. Pre-13,000 BP sites in Beringia look like Clovis and later sites in the south. Why isn't this true of other pre-Clovis sites south of the ice sheets? Now, I want to make it very clear that I'm not saying that these particular pre-Clovis sites have suffered from stratigraphic mixing and they're not stratigraphically intact. All I'm saying is, based on this statistical measure, they appear to be. And if we really wanted to know if they were, this could be answered by looking at things like refitting of artifacts vertically. We could look to see if there's stratigraphic variation in technology or raw material, for example, to see if artifacts below look different than artifacts above. There are various ways we could actually answer this question that would require additional analyses of assemblage at the site. But for the moment, this is a pretty striking pattern. So we have to find support for the Clovis-first hypothesis. I want to note that this is not normally how we address this question as an exercise of hypothesis testing, as a scientific exercise. I hope this inspires more people to do that and to find other ways of approaching the problem this way. Finally, I know that there's probably questions in the chat. I keep seeing the chat explode over here that you're going to ask me, but what about? What about these sites? And of course, these aren't the only pre-Clovis sites. You might bring up Cactus Hill, or you might bring up Chiquihuite, or you might bring up the Mastodon in California that I can't remember the name of. What I would say is these claims remain controversial. And for our study, we limited our study to sites with large numbers of artifacts, which these don't have, which generally, points out the obvious to me, that the pre-Clovis record of North America, at least south of the ice sheet, is very different qualitatively than that of Clovis in everything that follows. And you have to ask yourself why. Okay, with that, I will open this up. Thank my collaborators again. Before I open this up to questions, I want to say, I reduced an enormous amount of archaeological fieldwork down to a few simple statistics. This took a huge effort from many archaeologists working together, generously sharing their data. getting grants from many, many funding agencies, doing fieldwork over many, many years. It allows us to look at these big scale patterns. And I'm really grateful to all my collaborators for their willingness to participate in this and their help with this project. Okay, now questions.
Thank you so much, Todd. Very cool index, really, really tight study, and it's been really fun to hear you recount its creation and use. I don't know. Do you want to take a look at the chat and the Q&A yourself? Some of them are kind of long. Let me. I'll lead into one.
I'll let you moderate, maybe.
Yeah. Okay. I'll moderate a bit here. Let's start with a sort of practical one, which is super interesting and probably a lot of people thinking about. Very well phrased in the Q&A. How do you determine the vectors of disturbances moving artifacts downward in the stratigraphy? So how are they moving around? Can you tell us a little bit more about the formation processes there?
Yeah, I can. I mean, it's a good question. I would say we have some idea of the processes that move artifacts. Well, let's look at Cooper's Ferry here, okay? When we look at Cooper's Ferry and we look at this stratigraphic profile, you can see these white patches here, these dark patches here, big streak here. I'm not the excavator of the site, so maybe I shouldn't interpret that, but these are classic signs of what are called crotavina or rodent burrows, where animals have dug down through the site, and then those burrows have since been filled in with secondary sediments. And of course, artifacts are moving down with the sediments. So burrowing animals are one mechanism that'll do this. One well-known mechanism, whether we're talking about rodents, carnivores, even insects. Another one that's really important and shallowly buried sites like Barger Gulch is shrink and swell. If you have clay sediments, they get saturated, they dry out, then you get mud cracks, and then artifacts can move down within those cracks. Another important one is freeze and thaw, and what's known as frost heave, frost pull, can move artifacts, especially in the upward dimension. But I would say, after 20, 30 years of doing field archaeology, we don't entirely know all the processes responsible for moving things. It's very clear that things move, but exactly how all the processes involved, I don't think we understand them entirely.
Right. Very cool. One of the things you said at the beginning of the talk around if this were the case, if some of these sites really are this old, it implies really massive gaps in our understanding of what was happening at that time. And so just to kind of get the gist of some of the things in the chat where people are postulating, well, maybe more sites will be found, maybe with stratigraphic integrity, just more data, maybe more things will show up. What would it look like? Maybe talk a little bit about this hypothetical world. What would have to be found or show up to make this this graphic that you're showing here make some sense from just your understanding of people and population in the environment?
So this is kind of a mantra of this field of study. We just need more data, we need more sites, we need to keep looking because it's out there. And I will say that the Folsom site was found in 1928. The Clovis site was found in 1932, maybe? No, 36.
I think so, yeah.
And since then, lots of Clovis sites have been found. Since that time, we have probably excavated upwards of 50 to 100,000 archaeological sites. That is a massive, massive sample. There are very few problems in science that require samples of that size to definitively answer them. In fact, I can't think of any. So if we want to satisfactorily answer this question in my lifetime, and I certainly do, at some point we have to be satisfied that we've satisfactorily sampled this record.
Mm-hmm.
That's it. It's always possible there's stuff out there that's going to be older that we haven't found yet. So what would I expect? I don't think it's asking a lot of the archaeological record if you have people present to have a stratigraphically discrete occupation with 30 flakes in it.
Mhm.
Because that in the Clovis period is represented over and over and over again. I don't think it's asking a lot to have something like a bison bone bed in the area where I work. These occur from Clovis to historic times. They're highly archaeologically visible. They're not hard to find. Why don't they occur in pre-Clovis? I guess, again, I'm going back to the point that the pre-Clovis record is very, very different than the Clovis and after record. So is this because people were behaving differently? I don't see why they should have been. In Eastern Beringia, they weren't. Is this because we're not good at finding these sites? I don't think we're not looking. I think we're spending a huge amount of time and effort looking for it. So I don't